All right, guys, welcome to the next session. This is a deep dive into Nagios Analytics. And if you would please put your hands together for Alexis Le-Quoc.
Does this work? Yeah, I guess it does. Okay, my name is Alexis. I am been in development and operations for a while. I've been using Nagios since 2008, roughly, and I'm the co-founder of a company called Datadog, and I'll explain briefly what Datadog does. If you have any questions, actually interrupt me in the middle, because this is a kind of exploration into the data that we've collected, so yeah, feel free to interrupt at any point in time. So I would like to start with a little survey. And what I would like to do is for you to give yourself 5 seconds and think about the top 3 failed checks in your Nagios infrastructure. So just think for 5 seconds. Okay. So now who has a very clear idea of what they are? Okay. So who doesn't have a clue? I can raise my hand, but okay. So it's a little bit of a trick question that I asked you, because I didn't really say, according to how you rank, what's the top one and what's the bottom one. So it could be anything from, the top 3 that I responded to last week. It could be the last 3 that woke me up, and these, usually one tends to remember them. It could be the ones that I responded, 5 weeks ago, and that have been alerting and pinging me for the past, for 3 weeks in a row. It could be the top failed checks could be defined as, the one that most of my team has responded at least once, and so on and so forth. Or it could be the ones that actually impact the business the most. So there's a number of definition for the top 3 failed checks. You can pick whatever you want. The one thing, though, that I'd like to point out is, if you think about when I ask you to think for 5 seconds, if you step back and say, all right, so let's say I know what they are, what were really the criteria that drove me to pick those top 3? Well, I can speak at least for myself. The ones that I remember the most is the ones that wake me up relatively recently. So I think Monday at 5 a.m. I got a call from PagerDuty, so I remember that one very well. The one that I responded last week, it's a little bit more fuzzy. If I were to rank, if you give me all the checks and I were to rank them by the ones, tell me the ones that I responded to last week, I might remember, but maybe not. The one that I responded to, more than a week ago, forget it, I forget. Maybe what's more of a problem is that the checks that actually ping the entire team the most often, I don't really know what they are. And even maybe more worrisome is the checks that truly impact the business. I couldn't really tell you which are the top 3. And so, what we might, the little conclusion that I want to draw from this is that if we use our memory to prioritize remediation, if we do that exercise, basically even as a team, to decide, well, okay, so we have all these Nagios checks that have Nagios alerts. Which one should we attack first? If we use just memory and our brains, if you will, the results are likely to be really skewed. So I think at best, when you do that, we say, all right, this week let's meet, let's tackle the number of checks that have alerted, and let's resolve the problem. I think at best you find local optimums. So that might work for this week. You'll solve your top 3 checks so that they don't alert next week, and maybe next week it's going to be maybe the same, so you have a longer nights, more quiet, without being woken up, or maybe not. Maybe what you're doing is really Brownian motion, meaning that you fix things, other things break, you fix them, the first thing breaks again, so you have this kind of pattern of going all over the map without a strong direction. And you could argue that it's manageable. I think the problem is that as you grow your infrastructure, there's no, if you just use memory and kind of local response, really reaction, there's no guarantee that as the infrastructure grows, you're going to converge to a state where you can sleep entire nights. So that's basically what drew me, this little introduction, what drew me to think about Nagios Analytics. How can we get, which data can we get, what questions can we ask of the data to drive our efforts to say, okay, this week we're going to fix these 3 issues, and that's because these are the most, maybe the most important according to criteria, and the decisions that we make there, and this is what we're going to attack, are based on hard data, not necessarily on what I remember of the last week or what woke me up, and because my wife or my girlfriend is mad at me, and these are the ones we got to fix. So that's kind of the context of this little presentation. Any questions so far? Does that make sense? All right. Okay. So let me move on. So just a few slides about what Datadog does. It's important in the sense that it'll explain how we get the data. So what we do is we're a SaaS service that collects performance metrics, Nagios traffic, and a bunch of other stuff. So it all goes to one place. And then basically we give you back real-time graphs and analytics. So that's that's the gist of it. Now the important thing is that we do that because we're SaaS. We're running a SaaS service. We do that for a number of different companies. And so that lets us also not only tell you this is how for instance, these are your Nagios analytics, but also this is how you compare, or this is across similar customers, the kind of analytics that we're seeing. So very briefly, what we do is we collect. So Nagios is here. There's a number of other which you might know. You connect all that to Datadog, so it starts sending data, and then we basically give you analytics that look like kind of real time as with a little timeline and what's happening. Who's being pinged, who's responding to stuff, and it extends beyond Nagios. But in this case, of course, I want to focus on Nagios. Another way to do real-time analytics is that you can, since we get also performance metrics, we can tie together, like error spikes and then number of events that happen. So that's the general gist of it. Is once you aggregate everything into one place, you're able to make some interesting correlation between different sources. So, but I'm not here to give you an hour pitch on the company. Rather, I want to focus on Nagios traffic. So, I isolated that. So we basically connect to, we have a little piece of software that digests the Nagios logs, the current Nagios logs in real time, sends that to us, and then we do the real-time presentation, and we also crunch numbers in the background to produce our analytics, if you will. So from observation, from what we're seeing, and I'm going to focus on one particular account that we have. Nagios is a relative chatty source, so we're seeing a fairly constant stream of traffic. So one example is this is one of our environments. So it's a relatively small environment. It's 25 machines, 440 checks, nothing outlandish. So that simple environment generates about 13,000 Nagios events over the past per week, if you will. And then you can see that there's a kind of mix of things going up and down, up and down, up and down, up and down. There's the split between soft alert or soft or hard alert state, and recoveries is kind of split. So it's a lot of stuff that's happening. It's constant stream. Now, if I filter down by just the notifications, so things that sent us for this account actually pinged somebody, it's a lot fewer. Luckily, it's about 86 over the past week. Now, of course, what's interesting and really what makes Nagios Analytics interesting is there's a wealth of data, and although it's a lagging indicator for problems, it's a great way to correlate problems across the system. So here you can see last week around Saturday, there's kind of a spike of red that starts to happen. Turns out this is a graph of the number of rows that are pulled from a database, and this is basically time aligned, so you can see that around this time. This one, which is how many rows are returned by a web application, starts to go haywire. So it starts to take longer, the database slows down, the various checks in place say, hey, database slows down, we have too many logs, too many connections, and so on and so forth. So there's a lot of data in Nagios logs, and there's also, if you have some kind of dashboard or metrics system, you can start to do some really interesting correlation. So, any questions so far? Am I making sense? All right. So there's the interesting exercise that, what I would classify as interesting exercise I went through is led me to the very simple sort of premise that the more data you have, the more questions you can ask. So that's kind of a realization that I make once in a while because I forget about it. And what I'm going to talk about right now is really the dialogue that I had with the data. It's not a scientific study, so there's for various number of reasons that I can touch on a few, but this is really what I want to convey is how enjoyable it is to look into the data, and B, the kind of interesting insights that you can get out of it. So to recap really quickly, we have this, so we run this service, it collects Nagios log data from a number of different customers, and then I've sampled our customer base, anonymized the data, and so on, to be able to extract some interesting things. One of the reasons why it's not a scientific study, among many, many things, is that so there's no control for the size of population. So here in the x-axis, you see the number per account, the number of machines that our customers have, at least that the Nagios of our customers knows about. And here's the number, the pure count. So we have, see, seven customers that have between 0 and 10 servers, and 2 that have between 10 and 20, and so on and so forth. So the colors represent the quartiles. So the first, meaning that 25% of this population of different accounts sending us Nagios data, 25% has 20 servers or less, 50% the median is at 93, 75% has 322 or less, and then the top one has 904 servers in their Nagios. So as you can see, the population is not at all, the distribution is really, really skewed towards the small actors. So even that being said, I think the underlying question that's starting to emerge is, well, is there a difference, right? So you're a small shop, you have one Nagios instance and then 20 servers. How is it different? You probably have maybe one person on staff to manage the whole thing. How is it different? Do we see any difference between if you have 1,000 servers or more? So maybe you have a bigger team, more Nagios servers. Is there variability? And you think that, so intuitively I think, well, we're going to see some difference, right? Because maybe if you have a lot of servers, it can get really messy, and it's hard to manage. So we're going to see a lot more activity, a lot more Nagios activity. Or maybe you have a lot of servers, but you were able to reach that stage because you have a lot of automation in place, you have a lot of processes, and it's all running like a tight ship. So there's kind of questions that you're wondering about, and that's why I started this little experiment. So first thing is, does size matter? At least in the case of Nagios. So this is the quartile. So the first quartile, so 20 servers or less, 90, so between 20 and 90, between 90 and 300, and then over 500 or something like that, or between 300 and 500 and over 500. So, and this is the averaging per quartile. So this is the small accounts, the large accounts. What is the number of what is the number of alert per host, or failed check per host, if you will, and that's their distribution. So here, what you can see is that there's between, well, between 0 and 10. There's most of the, on the small players, we see basically few, maybe less than 10 alerts per host, and then it drops radically. And then here, as you go there, is like you can see that one, at least one host had on average 600 alerts. So, and let's see, with a little explanation. So, there's a strong mode around here, though. There it kind of goes. It's kind of a longer tail. And then there's a bunch of outliers. So the data here is the raw log, regardless of whether there's a notification at play or not. So regardless of whether somebody gets a page or not. So in here, in the outliers, we have machines that do have problems, and the problems are not addressed. And we also have checks that are just silenced. Like it's broken, it's silenced, it's never going to tell anybody, but repeatedly it says, I'm broken, I'm broken, I'm broken, I'm broken. And this is where we're seeing these outliers. Now, interestingly enough, and this is where the fact that the population of accounts is not representative, if you will, because we only have a few accounts with a lot of servers, 1,000 or plus, or 900-ish, so probably in the order of 1,000, is that they have a lot fewer outliers, so it's a lot tighter, which would tend to suggest that there's still stuff happening, right? Because their machines do generate Nagios traffic, but there's nothing that starts crazy and bombards everybody. That really stands out. Another explanation also, of course, is that it's average across a couple of months, I think. So when you have a small infrastructure and then you have a huge problem, it's likely to impact everything. And thus you start having, that's where the outliers might also mean that there was 1 week, there were 2 weeks where all hell broke loose, and then the Nagios stream started to generate a ton and ton of data. Any questions? Now, if we filter that down by notifications, I didn't draw that because there's not much to see, but there's actually not that much difference per quartile. So if you do the ratio of how many of my Nagios traffic, how many triggered a notification, it's very few, which is fortunate, which means that we running operations or as sysadmins are not being constantly bombarded, and most of the traffic is just silenced, and it's there. It's just silently collecting the data, but not waking somebody at night. And that makes sense, right? Because as your infrastructure, in your infrastructure, there's really a few key functions that will trigger, that will impact your business hardly, but most of, if you have 10 web servers and one goes down, it's unlikely that you're going to suffer, for instance, because if you have enough capacity, the rest will be able to absorb it, and they might not even need the need for you to wake up in the middle of the night. Another question that I was curious about is, does the time of day matter? So is there a worse time of day for observed hours that are more propitious to generating Nagios traffic? So that's important in the sense that the machines don't care, right? If something happens at 2 a.m. or at 8 p.m., it's just a different number as a timestamp. But of course, for us as people, if it happens at 3 a.m., it has consequences that are different from if it happens at 3 p.m. So I started to look at that. And so here it's a slightly different representation. Again, quartile, so the smaller, medium, large, extra large in terms of servers. And these are box plots, so they're meant, so this is hour of day, so midnight. This is all UTC to make sure that, so this is all UTC to make sure that the data aligns. And most of these data come from the US, so there might be, between East Coast and West Coast, there might be a 3-hour lag, but basically, so this is midnight UTC, which would be East Coast, like 8 p.m. or something like that. So that's kind of this is getting to the morning, and this is the rest of the day. So the box plot here, this is the average, the lower quartile, the top quartile, and the maximum. So it kind of gives you a representation of the distribution. Something that's interesting here is that the mean is actually about the same. So if you count the number of notifications, so people getting notified per hour on average across a couple of months, it's about once an hour. So of course, what that means is there are days where you don't get anything, and there are days where you get a 10. But there's no clear pattern. There's no like one at least in terms of the mean. There's no, especially for these guys, there's no clear. So there's no clear pattern. Here, so when you have there's a lot more variability on the smaller and the bigger end size. So it's smaller, it's kind of all over the place here, so it could be that just the population of the small accounts is so varied that it's all over the map. I think for the bigger accounts with 1,000 servers or so, there's clearly something around that time, which I haven't been able to figure out why exactly, but it might be related to the particular business they're running. But I found the thing that was interesting, and I found is that the mean is the same. So it doesn't really matter. Basically, the time of day does not really matter that much. So the next thing was to figure out, well, does the day of the week actually matter? Is there a worse day where you shouldn't plan to go to the movies or watch TV or plan a date or something like that? So similar representation, though in this case it's the total. So what you can see is the quartile, so smaller, 20 servers or less, 20 to 90, 90, 300, and 300 and over. It's kind of all, it's average, of course, but it's kind of all the same. So there's no, there's some variations, but nothing to speak of. So it's not like Monday night is the worst day ever. It's not, it doesn't stand out like it. So nothing happening there. So the next question is, all right, well, with all this data is, what about squeaky wheels? So by squeaky wheels, I mean in terms of check, what's the distribution of problems based on a check? So in other words, do we have this one check that's going to bother you all the time, and then the rest are quiet, or is it like every single check is kind of bothering you, equally, if you will? So is there a squeaky wheel in your checks? So so I got this when I ran the analysis. So again, quartile here first. The first thing that stood out is like, whoa, there's something wrong here. So there's a big outlier, and again, because we have a sample size of about 30 different Nagios streams that we're analyzing and not 1,000, the outlier is it's more sensitive to outliers. The data is more sensitive. So what I did then is focus, zoom on it. So there's one particular account in our data set that had this kind of distribution. So there's one check, the first check, is alerting 30 times an hour. The second one is at 27, and the third one is at 7, and then there's a long tail. So here, this is obviously for this particular account, it's obviously something that's badly broken, and that went badly broken for a while. But now, if I remove that data, so remove the account that has this big outlier, the distribution looks a lot more like a long tail. So I actually am not sure if it's parallel or anything. I haven't run the data for that, but you can see that there's basically, there's a little bit of variation, but there's this clear pattern where you have a few squeaky wheels, and relatively quickly then you end in the long tail. The only reason why the tails are a different length is because it's just how many different checks the various accounts have. So if you have 20 machines, you have 5 machines, maybe you set up Nagios relatively quickly with default checks. Thus you end up with 15 checks total or 25 checks total. Whereas as your infrastructure grows, you're more likely, you have time, you have the team, you want to get deeper instrumentation, you're more likely to instrument like hell and have a ton of checks for every single thing in your that's moving in your system. Good so far? So same question about the about hosts. So again, in your infrastructure, is there a squeaky wheel? Is there one host that has a problem? And it could be that that particular machine has hardware problems, worst case like memory problems that kind of throw things off track in a very very hard to predict manner, and that might actually be a way to find out. So again, quartiles: small, medium, large, extra large. The ranking of the hosts per amount of Nagios activity that they generate. And then let's see what it looks like. So again, I found the exact same outlier for the same account. So they had something going wrong. It's a very similar pattern, right? So it's a huge, almost exponential. I mean, looks like an exponential distribution of problems, which means that they probably had like 2, 3. Well, they had 1, 2, 3, 4, 5. So if you count, so 1, 2, 3, 4, 5, 6, 7, about 7 machines that are generating the bulk of traffic, and the rest is kind of equally silent or chatty. So for them, it's a great way to find out, well, we should focus on those guys, because that's where the pain is coming from. And once that's solved, then you can see what it looks like. Now, if we remove that that outlier again, we kind of get the same long tail distribution. So, which means that you'll still tend to have one check, one host. So there's always you have a few targets you can focus on to eliminate that peak, and then as you go down, as you start solving, so figuring out exactly why they're sending you notifications, then the more time you spend, you're not going to get as many returns on your time spent, as it were. So return on the investment, as it were. Good questions. Does that match your experience? No? Yes? Okay. All right. Well. So the next question that I asked myself is, from a time span perspective, what is the pattern? So do you have something breaks here, and then there, 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 or it kind of recurs all the time in one place? So it's a slightly trickier question, and this is the representation which I need to spend a little bit of time explaining. So the quartile expressed in colors doesn't really matter in this case, but the x-axis is the age of the alert. So that is the time that's elapsed between the first time we saw it and the last time we saw it. If you see something, you fix it right away, never reoccurs. The age, it's what we could qualify young. It's a survival rate, if you will. It's going to be there because you saw it, you fixed it, and then boom, it never reappears again. If you have checks that fail every week, and it's the kind of checks like, yeah, I know, yeah. They're here. They tend to be on that part of the axis. The y part of the axis is how often they happen. And that's the number of different days where they reoccur. So here it happens every day. Here it happens like once in 6 months, give or take. So by construction, there cannot be any points beyond in that area, because that's actually the number of days, the age versus the different days of occurrence. So meaning that, what I mean by that is, as you get closer to the axis, it means it occurs often, and as you get further out on the x-axis here, they happen once in a while. They've been going on for a while, but it's also only once in a while. So it's the check where, yeah, okay, it's once a week it happens, or once a month, and then you deal with it, and then you move on, because life has better to offer than that. Here is what I would say tolerated. So it's been going on for a while. You know it exists. It kind of happens often, but it's not that bad. So maybe it's a thing that, for every week you just, yeah, okay, this I understand. Just want to, I'm going to acknowledge it, and then I'll resolve. So it's something that happens relatively frequently and has been going on for a while. The bad guys are here. So from a priority perspective, because they're the checks that have been going on for a while. So the failures, I'm sorry, that have been going on for a while. So it's been failing for the past. The first time we heard about it was 200 days ago. The last time we heard about it was very recently, and it's almost happened every single day. So I don't want to be here, because that means that this is like constant traffic. Say, hey, it's broken, and the next day, hey, it's broken, and the day after, hey, I'm still broken. And this is like whack-a-mole kind of thing, and I don't think it's a good pattern. So that's kind of the really quick number of questions that I was asking myself as I was looking at the data. And I think again, the more questions you have, the more data you have, the more questions you can have. One thing I didn't do a longitudinal study where you focus on one particular account, for instance, and see how they evolve over time. So that's something that's super interesting, because that's going to tell you how whether you're improving or whether things are getting worse. Now, I have another presentation on how I put together the data, but I can give you basically some ideas. So the data where we aggregate from a number of companies, so that's through our service. If you want to do this yourself, so I'll explain more tomorrow, but basically with a combination of some parsing, some database, and then a statistical engine plus visualization libraries, then you can get the similar results. And out of curiosity, is anybody using these tools? Or I guess to the right. I'm sorry. Like, are you guys using R or Excel or I don't know, SSPS or to crunch through your Nagios data? Okay, it's great. It's great. I really recommend it. I guess I'm getting to the end of the presentation. Presentation matters. So this is one of the analytics that we serve to our customers. So this is specifically, it's actually for one of our development account. So where it's interesting to, the kind of insight you can get out of your Nagios stream is, so week by week, how you're doing, which are top alerting hosts, top alerting checks, and then kind of the, by hour, by day and hour. So I guess that was last week. You see that we have a pattern around for our particular account. We have a pattern in UTC, on Fridays and Saturdays. Kind of it did get a little bit busy around 8 a.m. And I think I remember because I woke up Saturdays, drink some coffee, and then my email is starting to boom, boom, boom. There's a number of issues. And the thing we're trying to do is also give you some actionable insights. These are the ones that have been bugging you for the past 3 weeks, so maybe you want to do something about it, or the ones that are changing the most. So Datadog provides this kind of data as part of a service, but you can get, the illustration or what I wanted to convey in this presentation is that you can get similar data. It takes a little bit of coding, but you can do it. And I'll explain how I did it for this particular presentation tomorrow. So a couple of takeaways. So don't rely on memory to prioritize, because you're going to skew your action towards the recent painful stuff. Partly also because the old painful stuff tends to be toned down. Your Nagios logs are a treasure trove. There's a ton of stuff that you can get, and it's a great way to direct your action, your remediation. This is what we should work on this month, because these are the things that matter. I think it's really fun, and this is personal, so you might disagree, but I think it's really fun to have a dialogue with your data. Once you start getting the data properly formatted and you load them in R, you can really quickly get graphs and then look at different things. It's easy to get lost, but it's a lot of fun. And then last is presentation matters. So, and I hope I didn't do too bad a job there, but in the sense that the raw data, if you if you have them in R, in Postgres, or in some SQL database, it's great, but it's not, you need to present them. You need to obviously spend some time presenting them so that they're actionable. You can digest them. And more importantly, while I spend, I don't know, maybe 4 to 8 hours crunching the data, I have some good grasp of the results that I could extract from it. But somebody else in my team who hasn't spent the same amount of time, if I showed them without giving them any of the presentation that I've just given you, okay, here are the graphs. They'll be like, okay. So I really want to spend, really matters. The last takeaway, this is just the final plug, is if you're curious about Datadog or if you like Q logos, because we're told we have Q logos, you can hit this URL. So this is just our website. And sign up. We'll see. So that's that concludes my presentation. Any questions? Well, actually, yeah, I'll.
Come on, guys, dig down.
Does that? Did the data, match your experience or if it didn't, like, do you care to share? I'm really interested in seeing what your experience is in terms of, or how you attack this particular problem.
It looks like what I would expect to see to a large degree. The question I got in terms of other types of analysis is whether you've ever looked at, especially on network devices, if you looked at any type of patterns by the size of the device. I was surprised. We recently took over doing some field service dispatching for a network vendor. And one of the things that we were surprised to learn from their statistics was that in at least their instance, the number of alerts per device did not vary with the number of network interfaces on the device.
Okay.
It tended to be constant across all sizes of switches.
So what was your conclusion? That it was?
It looked like the majority of the alerts were not interface specific. They had to be something more in the OS or in the motherboard, but and the interface alerts these were call home alerts rather than interface down necessarily. So,
right.
So it made some sense that it would work that way. We still were surprised that as the complexity of the device increased, the number of failures didn't.
I see. And how often did you run that analysis?
That was an analysis based on a period of, I want to say, 6 months to a year
okay.
of call home events.
I see. Okay.
My question might segue into your presentation tomorrow, but are you processing the raw log file, or when there's an alert, does it send it off to like a database, and then you process stuff from that database?
So, so it started with the log file. It's the same. So whether for this I ran, well, so if you want to do it yourself, so you can basically parse your log file, spit that in the database, put that in the database, and then connect the stats engine to it. What we do as part of the service is that we parse the log file. Instead of sticking in a database that's on the host, we just send that over the wire. And then now we have a database that spans multiple accounts. So then we run like MapReduce jobs to assemble them. But if you have one single, a few servers, from a pure scale perspective, you don't need to do MapReduce, right? When I ran there, you can run it on a box, on a Postgres box, and then use R to connect to it. But I'll present a little bit more of that pipeline tomorrow, and hopefully with some code behind it.
Other questions, gentlemen?
If the last thing is, if you want the data set, I can share the data set itself. So it's aggregated. There's no nominative data about any account, but it's you might want to use to just get started and play around a little bit. So I can share that on GitHub. Cool.
Well, if we have no other questions, how about a round of applause for Alexis Le-Quoc?
Thank you. Thanks.